Good day. In today's video, we will be discussing about discrete random variables and their probability distributions. So first, let's define random variables and what are the different types. Actually, here is two types of random variables, which are the discrete random variable and the continuous random variable. So by definition, a random variable is a variable whose value is determined by the outcome of a random experiment. So to become a random variable rather than simply a variable, it must be the value of that particular variable must be determined as by the outcome of a certain random experiment. So, and then we have also a subtype of a random variable is the discrete random variable, which is a random variable that assumes countable values. So here are some examples. So the number of cars sold at a dealership during a given month. Now, it's different from simply variable, which is the number of cars sold at a dealership. It becomes a random variable because it's the number of cars sold during a given month. So it's basically a random experiment. That's a given month. We can consider that an experiment. And the random variable is now the number of cars sold at that particular month, which is the outcome of a certain experiment. So the outcome is the number of cars sold, and your experiment is, well, the selling at the dealership on that particular month. So here also the number of houses on a certain block. The experiment here is, well, determining a particular block. And then you have the number of fish caught on a certain fishing trip. So here is the difference again of variables, simply variables, and a random variable. So again, the number of complaints received at an office of an airline on a given day, the number of customers who visit a bank during any given hour, and the number of heads obtained in 3 tosses of a coin. So that's your discrete random variables. So in contrast, you have continuous random variable. So the continuous random variable can assume any value contained in one or more intervals. Actually, it's very similar to a continuous variable, except that it must be, of course, an outcome of an experiment, of a random experiment. So, for example, in this interval 0 to 200, every point of this line represents a possible value of x that denotes, for example, a battery life. So, there's an infinite number of points, and therefore, you have the values represented by the points on this line are uncountable. But this corresponds to a continuous random variable. So, examples, the length of a room, the time taken to commute from home to work, the amount of milk in a gallon, the weight of a letter, the price of a house, and even the money. Technically, money is not supposed to be a continuous variable, but it becomes a continuous variable. We usually treat them as a continuous random variable. Example here is the exchange rate from peso to dollar. So you have, when you look at the exchange rates, that's say from $1 is equal to 50.35 something peso. So we look at it, you will have a lot of decimal points coming there. So it's not categorized into a certain discrete variables, but that is a continuous number. So, probability distribution of a discrete random variable. So, in this topic, in this lecture, we will be focusing on the discrete random variable and the probability distribution. The probability distribution of a discrete random variable, by definition, lists all possible values that the random variable can assume and their corresponding probabilities. So just a recap from your previous lecture, you have here, we will be applying here the idea of probability. So not only identifying all the outcomes, but rather in a probability distribution, we also need to know, or we will, it actually tells us how probable a certain outcome is, a certain discrete random variable or a certain discrete outcome is. So that's your probability distribution. So it will list everything, all possible. For example, what are your chances of your grade in this quarter, first quarter in, say, biostatistics? So you will have here the list of all possible values. So let's say 1 flat, 1.25, 1.5, all up until 3.0, then 5, then we have IP and I. So these are all possible values. And as not only we will be listing that values, the probability distribution also show us how probable you will get a particular grade will be. So, for example, if you are going to get 2.0, so that's say a probability of 25%. So you're going to get a grade of 1.5, that's a probability of say 15%. So something like that. So that's your probability distribution. So example here, the frequency of a relative frequency distribution, the frequency and relative frequency distributions of the number of vehicles owned by families is given in the table in the next slide. So let X be the number of vehicles owned by a randomly selected family. Write the probability distribution of X and make a histogram for this probability distribution. So here is the number of vehicles owned, and after the experiment, that's the frequency each number occurs. So we have 30 respondents owning 0 vehicles, 320 respondents owning 1 vehicle, 910 respondents owning 2 vehicles. So we will get the frequency, the relative frequency of each category, or rather each variable here. So these are the outcomes of your experiment. So the probability of each is this one. So this is the relative frequency based on the experiment, how often these variables, these outcomes showed up. And so you have here, now the probability now is actually, we can actually relate it to the relative frequency. So from our previous lecture, getting the probability using the frequency distribution principle. So you will have here the frequency, the relative frequency is basically your probability. So you will get here, so the total mass all be equal to 1.00. So here is the histogram. So what's the difference between a histogram and a bar chart? So a bar chart, basically, it should have spaces in between. But a histogram, it's a probability distribution. So you have here in your y-axis is your probabilities, and these are the possible outcomes. So this is your histogram. So this is you can say that this is a histogram for a discrete probability distribution, because it's not the bell chart that you are used to seeing when we look at statistics. Not that is actually for continuous, but for discrete probability distributions, you will see there are jagged edges, because you have here technically discrete variables or discrete values in each particular histogram, and we will not see here any curved line. So meaning this is just 1, this is 2, this is 3, and this is 4. So there is no 3.5, 3.25 here. So, two characteristics of a probability distribution. So, the probability distribution of a discrete random variable possesses the following two characteristics. So, the first one is the probability must be between 0 and 1 for each value of your x, which is your outcome, and the total probabilities of all outcomes must be equal to 1. Actually, very similar to the characteristics of probability. So another example, the following table lists the probability distribution of the number of breakdowns per week for a machine based on past data. So for a week, there's a probability of 0.15 for no breakdowns in that particular week, a probability of 0.2 for 1 breakdown, a probability of 0.35 for 2 breakdowns, and a probability of 0.3 for 3 breakdowns. So what is find the probability that the number of breakdowns for this machine during a given week is exactly 2, 0 to 2, more than 1, or at most 1. So let's denote here x, the number of breakdowns, 0, 1, 2, and 3 for the machine during a particular week, and this is your probability from the table. So this is coming from the previous table from past data. Okay, so from the past data, we will get the probability frequency probabilities using the frequencies. So relative frequencies. So 0.15, 0.20. These are the relative frequencies of each breakdowns from past data. That is why some statistics is actually important to get data, past data, to predict certain outcomes. This is statistics. Okay, so I have here the table on this left side, so we can say. So the first question is exactly two breakdowns. So just a probability of having two breakdowns. So if you look at our table, this is 0.35. So that's exactly two breakdown. The probability is 0.35. Now, probability of 0 to 2 breakdown. So between, basically it's a union of the breakdowns of 0, 1, or 2. Probability of 1 to 2 breakdowns. So it's, the calculation here is just add, because it's a union, 0 or 1 or 2 breakdowns in a particular week. So you will have here the probability of, so you will now have here, basically just simply add everything. So the probability of 0, that's 0.15, plus the probability for 1, that's 0.20, and then plus 0.35, which is probability for 2. So just add them. So application of the previous topic on probability. Now, the probability of more than one breakdown. So anything greater than 1. So that's 2 or 3. Not 2 and 3, but 2 or 3. So you have here, just add probability of having 2 breakdowns plus probability of having 3 breakdowns. So this is actually union again. So that's 0.35 plus 0.30, that's 0.65. And then probability that there's at most one breakdown. So again, at most one, that means none or one. So 0 and 1. Or rather, since it's a union, it's 0 or 1. So this, add those values, you get 0.35. Okay, so another example here. So according to survey, 60% of all students at a large university suffer from math anxiety. So two students are randomly selected from this university. Let X denote the number of students in this sample who suffer from math anxiety. Construct the probability distribution of X. So for the solution, so first define the events. So let's just say N is the student the student selected does not suffer from math anxieties, and M, the student selected, suffer from math anxiety. So here, how do you get the values of 0.16, this 0.48, and then 0.36? We can actually look here at the solution diagram. So going back to our problem, the problem here denotes that 60% of all students suffer from math anxieties, and two students are randomly selected. What is the probability of each student having each particular combination of anxieties? So 60%, that means from the past data, 60%, M is the probability of getting an M for a 1 chance at 60%. That's 0.60. So if you look at the first, it's actually somewhat similar to a coin toss, but done twice. So the first selecting the first student, since excuse me, since 60% of students suffer from math anxiety, which is denoted by M. So among, say, 100% or the whole student body, 60% or 0.60 is the probability of getting a student that suffers from math anxiety. And of course, by virtue of the second property of probability, so the remaining must not suffer from math anxiety. So that's 0.40. So the probability of so for the first student, the probability of not getting a student that suffers from math anxiety is 0.40, and getting a student that suffers from math anxiety is 0.60. Now, in the next selection, so just like a coin toss, so you will have again the same probabilities from this student body. So 0.60 and 0.40. Now, since this is a selection of two students, so for example, if the selection is two students of getting N, it's a probability of getting N and a probability of getting N on the second chance. So this is basically intersection. So it's a probability of N, sorry, N, the not probability of not getting a student not suffering from math anxiety, and again another student not suffering from math anxiety. So it's a multiplication rule. So you will get 0.40 plus 0.40, that's 0.16. So the probability of getting both students that do not suffer from math anxiety is 0.16. And then what if here is your combinations? So a probability of getting the first student not suffering from math, or rather a mix of student get suffering from math anxiety and the other is not, is basically if the first draw or first selection does not suffer and the second exceed, this is basically a union scenario, sorry. This is a union scenario. So the second outcome is getting a student that suffers, or rather, one student that suffers from math anxiety, and the next student does not suffer from math anxiety. So if the first student selected does not suffer, and the one also suffers from math anxiety, so that's 0.40 times 0.60. So that's 0.24. And then again, 0.60 times 0.40, that's 0.24. Now, since both of them are, although we can say these are permutations, but the combination of one student suffering from math anxiety and students that does not suffer from math anxiety, this is the union of these two probabilities. So 0.24 plus 0.24, that's 0.48, and that's actually what this means. So the probability of at least one student suffering from math anxiety among the two selected is the probability of the two scenarios. The first student not suffering from math anxiety and the second student that suffers, or the first student that suffers and the second student that does not suffer. It's the either or scenario. So it's a union of two sets. So we're just going to get we just sum up the probabilities of these. So this is 0.48. And lastly, the probability of getting both students suffering from math anxiety is here. Since this chances here is 0.60 and another 0.60, so you get 0.36. So this is the final outcomes and their probabilities. So again, the probability of getting a student or number of students suffering from math anxiety given two students, so selecting two students, so you will just get, this is your table of distribution. So if you add them all, you will get a number of 1.0 for the probability. So that's basically probability distribution. So this is the list of possible outcomes if you select two students, and this is the probability of getting the chances of getting that particular outcome. So that's your table probability. This is actually your probability distribution. So let's look at the mean and standard deviation of a discrete random variable in the next part of this video.